All right, IM2 classes. Uh, Today we're starting off with absolute value functions. What we're actually going to be doing is transforming an absolute value function. So let's get right into it. We're not actually maybe we'll be graphing absolute value, but first lesson before we get there, we're going to talk about parent functions and transforming them. So for any function, there are four basic ways to transform the shape of its graph. The original function f of x, you might remember the f of x notation from IM1. It's called the parent function. So the parent function is the starting function, and we move it up and down, left and right, stretch it out, shrink it, that sort of thing, based on the original function. We're going to go over those transformations, and then we'll apply them to the absolute value function as a parent function. So a vertical translation, that's a shift. The graph moves up or down. All right, horizontal, the graph is moved left or right. All right, a vertical dilation, contraction, reflection. In the vertical direction, the graph is either stretched, shrunk, or flipped. And that's for each of those. It's going to be the same for horizontal dilations, contractions, reflections. It's the same thing as here. But for us, we're not going to worry about these. Reason for that is a vertical stretch is a horizontal contraction. So they're related. For IM2, it's just easier to focus on the vertical than worry about is it vertical, horizontal. You can do either one, vertically or horizontally. So here's a general function, f of x. It's just a random function here. The points here. I'm going to label the graph, so it's going to go 1, 2, 3, 4. So this point is at -4 in the x, up 1. This point here is left 1, up 1, so that's -1, 1. This point here, that's right 1, up 3, so that's +1, 3. I'm not going to fix that. You can tell it's a 3. Over here, so this point down, it's to the right 2, down 3, so that's 2. And then it's -3 in the y direction. And then 1, 2, 3, 4. So that's 4 in the x direction. It doesn't move up or down, so that's 0 in the y. All right, what I'm going to do is quickly, I should have done this before I started the video, is plot these points on here. So this is the parent function, and we are going to stretch it based on what it says there. So I'm going to plot these points. I'm going to do little dotted lines to connect them. So again, here, here, here. Nope, down one more. It's easiest to do this if you have the points in place. Again, if I would have thought about this to make it easier, I would have had this in place before I started the video, but your packets don't have this in here, so you're going to want to do this anyway. All right, so from here, +3. So when you add 3 to the x, f of x, so we're going to take this f of x, we add 3 to them. So if we just think about the f of x, that's going to shift everything up 3. I'm going to change the color on this. So when the +3 or minus, or we'll get to the minus in a minute, but when it's outside of the function, outside parentheses, this is going to shift everything up 3. So each of these points is going to go up 1, 2, 3. 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 We could add 3 to each of these. You can see where it's at. I'm going to save some time and just count it out here. All right. -2. If we -2 from each of these, they go down 2. So this is going to be a shift down 2. All right. So that's going to be down 1, 2. down 1, 2. I will fix that one because that's on the other graph. That can be confusing. This one here, down 1, 2, down 1, 2, and this point down 1, 2. And connect the points. So if you're adding or subtracting outside the function, you're going to shift up. If you're adding, down. If you're subtracting. Here, when it's inside the function, you can see how it's inside the parentheses here. This is going to be a little bit trickier. So this is going to be a horizontal shift. And you would think that you would just be to the right one because +1, that's 1 in the x direction. The way it works out it's actually opposite. When it's inside the parentheses, it's opposite. So that's going to go to the left one, each point to the left one. That might be confusing right now. What you need to remember is opposite. When we get into an actual function and we're switching these, it's going to make more sense. And I'll explain it better in better detail here. But right now, all you need to know, when it's plus or minus inside the parentheses, inside the function, it's going to do, it's a horizontal shift and it's the opposite direction you would think. So it's to the left one on each of these. I don't know why it puts in those random lines. It just does. Delete that. And then connect the dots. All right. We have a few more. Oh, goody. I get to put in the parent function again. So I believe that was it. So I'm just going to put in the parent function on all of these real quick. And that way we can just move from the points. All right, last one. And I'm going to put in just quick dotted lines. Good thing you can just fast forward through all this. All right, so here. This one here, it's inside the parentheses, so it's a horizontal shift. It's going to be opposite what you think, so I'm going to shift this to the right 2. So every point goes right 1, 2. Here 1, 2. Here 1, 2. Here 1, 2. And 1, 2. So just remember, it is opposite of what you would think, shifting to the right. This is where it gets a little tricky. This is a vertical stretch times 2. So I'm going to take all of the y values here. So yeah, I'm going to take all the y values and multiply them times 2. So this y value is 1, so I multiply that times 2, and so that gets stretched to 2. So another way to think about this is going to stretch the distance away from x. It's going to pull everything further away. It helps if you picture these points here. If you picture a piece of string and you pull those points, you're going to stretch it away, and it's going to get twice as far away from the x-axis as this. So this one is has a distance of 1 away from the x-axis. So when I multiply that distance times 2, 1, 2 is going to be my new point. All right. So this one, another distance of 1. So the new distance times 2 be right here. This one has a distance of 1, 2, 3. So 3 times 2 is 6. So I'm going to do 1, 2, 3, 4, 5, 6. All right. So again, this one has a distance of 1, 2, 3. So I'm going to multiply that times 2. So this is 1, 2, 3, 4, 5, 6. This one's on the y-axis, so it doesn't change. So here, And I know there's a lot of fruit. Wow, that got real ugly. But yeah, so it's you take the distance, how far it is away, and you multiply that distance by whatever the factor is. My video stuff just got in the way. Um, yeah, yeah. There we go. Okay. Um, so this one, it's -1. This is going to be a flip. So all these points are going to flip to the other side of the x-axis, and they're going to be the same distance away. So this one is 1 above the x-axis. When I flip it, the new point is 1 below. All right, this one is flipped 1 above. When I flip it, is 1 below. This one is 3 above. So when I flip it, it goes 1, 2, 3 below. This one is 3 below. So when I flip it, it goes 1, 2, 3 above. And this one is on the x-axis, so that stays there. So it is flipped. And just be careful when you're connecting the dots that it's all flipped like that. All right, so this is another shrink. So sorry, I should put, this is a stretch. This is a shrink. So instead of pulling it away from the x-axis, we're going to flatten it down towards the x-axis, and it's going to be half the distance. So this is 1 away from the x-axis. Half that distance is going to be 1/2. So we got to do a half there. Okay. This one, same thing. That's 1 away, so that's going to be half the distance. What am I pushing that? It's making it do that. What the heck? Not what I wanted. There we go. All right. This one is 3 away from the x-axis, so I multiply that by 1/2. So that's going to be 1.5. So I'm just going to cut the distance in half. Same thing with this one, cut the distance away from the x-axis in half. This one's on the x-axis, so it stays there. And we can connect the dots. All right, so let's write out all these rules. A vertical translation up. That's going to be your f of x plus some value k is going to shift it up. If you're going to shift down, that's going to be your f of x minus some value k. All right, horizontal translation. That's going to be to the left. That's going to be f of x, and it's going to be inside, and it's opposite since it's left. That's going to be plus some value h. And to the right, we're going to have f of x. It's all going to be on the inside. That one is going to be minus. Again, the horizontal translations are opposite of what you would think. The vertical stretch. So that is going to be your f of x. And you're going to have your a. It's going to be multiplied by an a. And for this one, a is greater than, or I'm going to say the absolute value of a is greater than 1. So anything greater than 1 is going to stretch it out. The shrink. You need a little bit more space. So f of x, that is going to be, you're still multiplying by an a, but a, the absolute value of it is going to be in between 0 and 1. So anything between 0 and 1, so a fraction that's less than 1 is going to shrink it. The flip, anytime you flip it, it's going to be the same a. The f of x, you're still multiplying it times f of x. But a is negative. So whenever it's negative, it's going to flip it over the x-axis. So for these, you just need to describe the translation that's happening. This is not too bad. So it's going to be, first we have some shifts. -1, that's to the right one. +2 is a shift up 2. So inside is horizontal. This one is vertical. Right one up 2. Another shift. This one inside. So that's going to be left 7, up 7, or up 8. So it's opposite what you think here. Positive here. The stretch, we can say stretch by a factor of 2, but I'm good if you just say stretch. So the 2 stretches it. And then the -1 is a shift to the right 1. All right. So we have 3 things going on here. First, the negative flips it. So I'm going to say flip. The 3 stretches it. And then the +2 on the outside is a shift up 2. So the negative, the 3, and the +2 all do something different. So this one, the 1/2, that's a shrink. By a factor of 1/2, we can just do shrink. And then that's going to be a shift down 9, since that's outside the parentheses. So again, this one we have 3. We have the negative, which flips it. The 3/4 is a shrink. The +6 inside the parentheses is a shift to the left. It's opposite of what you think, left 6. This one we have a stretch. The 2 on the outside multiplying stretches it. +3, so that's going to be a shift on the inside. That's a horizontal, and it's opposite, so it's left 3, and then the -5 is down 5. Over here, the negative, that's going to be a flip. The negative on the outside, and then we have a shift. That's going to be right 4, up 7. And then last one, the 2/3, that is a shrink. And then we have a shift. The +1 is inside the parentheses, so that's going to be left 1. +5 outside the parentheses is up 5. And that is all we have today. Next time, we'll do those with absolute value functions.